Hi everyone. What we're going to be working on is an example that uses law of sines. What you can see here is that we have an angle and a side and a side. Okay, angle, side, side. If we were to draw this, we would see that it looked kind of like this. Angle, side, and then the other side A would be over here. So what we're going to have to check for is whether we are able to form one, two, or no triangles. So the first thing we're going to remember is that we have an acute triangle or an acute angle given to us, and the side opposite that angle is less than the other side that's been given. Okay, so because that's the case, we're going to compare A to B times the sine of angle A. So in this particular case, it's going to look like this, 40, and we're going to see how it compares to 50 times the sine of 51. Well, 50 times the sine of 51 is 38.9. So obviously 40 is bigger than that. And what that tells us is we are going to have two distinct triangles that could be solved using this information. So what I like to do is kind of organize my paper. Okay, I'm going to erase this right now. This was just to show you what, sorry, what this was going to look like. And what I like to do is on this side here, I'm going to do the acute scenario, which would be case number 1. And over here, I'm going to leave work for the obtuse scenario or case number 2. So the first thing is it starts off like any other law of sines problem. So we're going to have to draw our diagram. We know we have a 51-degree angle that's been given to us. Okay, so I'll call that angle A, which is 51. And we have side B, so this is going to be angle B, angle C. We know side B, we're not sure of yet. And side C is 50 and side A is 40. So using the law of sines, we can clearly see that we have this angle, angle A, and the side opposite that. So we'll be able to use that to calculate the measure of angle C. So we'll set it up. The sine of 51 is to the side opposite that, which is 40, as the sine of angle C is to the side opposite that, which is 50. And we're going to have to cross multiply as we always do and then divide. So I'm just going to kind of jump to the chase. The sine of angle C equals 50 times 41, 50 times the sine of 51 divided by 40. And remember, that would have said 40 times the sine of C. We just divided to the other side. And now, of course, in order to undo taking the sine of the angle, we take the inverse sine, and we have to do that to both sides. So inverse sine of each side. When you put that into your calculator will default to the first quadrant, or the principal values, which in this case will fall in the first quadrant, and you'll get that the measure of angle C is 76 degrees. But here's the deal. Because our calculator defaults to the first quadrant, we have to think about what other angle would give us the same value here. And we're dealing with sine, and we know sine is height. So we have a 76-degree angle here. Well, we know that in quadrant 2, we would also have the same height if we were given a 76-degree angle. So what we have to ask ourselves is, what angle gives us a 76-degree reference angle in the second quadrant? And it's easy. You just do 180 minus 76, and we find out that this angle could have actually been a 104-degree angle. So in other words, the supplement of 76. That gives us the second scenario, where we would say, hey, the measure of angle C might not have been 76. It might have been 180 minus 76, which is 104, which would create a completely different triangle for us. Looking at it, angle A would still be 51 degrees, but angle C would now be an obtuse angle at 104 degrees. All of the other information that was given to us at the beginning would remain the same. So we would still have side A having a length of 40 and side C having a length of 50. The only difference is this triangle on the left, our acute triangle, will have a 76-degree angle at angle C. The second scenario will have an obtuse angle at angle C at 104 degrees. And now we just go ahead and solve these problems like we would as if they were two separate problems. So we can look here and we see, okay, in this scenario to the left, the acute triangle, we have two angles. So what we can calculate at this point is the measure of the third angle. And we're simply going to use the triangle angle sum theorem. So 180 minus 51 minus 76 gives us an angle, the remaining angle, to be 53 degrees. So angle B is 53 degrees. And now we'll go right back to law of sines. Got to make myself a little bit of room down here. We'll go right back to law of sines to go ahead and calculate the remaining side, which is B. As I always tell you, go back to what you were given at the beginning. So we'll start with the sine of 51 is to 40 as the sine of 53 is to side B. And you're going to cross multiply and then divide. So you'll get B equals 40 times the sine of 53 divided by the sine of 51. And if it takes you 2 steps to get there, that's fine because you're going to cross multiply and then divide by the sine of 51. When you put that in your calculator, make sure you either use the fraction key or parentheses correctly around 53. What you should get is 41.1. So this is 41.1. Let's make sure our numbers and our answers are reasonable. The biggest angle is opposite the longest side. The smallest angle is opposite the shortest side. And if you look, 51 and 53, it's almost isosceles. So 40 and 41.1, almost isosceles. So we've solved for the acute case. Now we go ahead and we do the same thing with the obtuse case. And it actually follows the same steps. We have to go ahead and calculate the measure of angle B. In this case, it would be 180 minus 104 minus 51. So the measure of angle B is 25 degrees. So you can clearly see we're dealing with a different triangle because of how those sides fell. And now that we have that, we'll go ahead and we'll use law of sines again to calculate the length of side side B. So again, go back to what you were given. So the sine of 51 is to 40. And now use what we just discovered, that angle B is 25. So the sine of 25 is to side B. And when we cross multiply and we divide, we will get B equals, we have 40 times the sine of 25, all divided by the sine of 51. And I'll say it again, if you need to do that in a few steps, do it in a few steps and get it right. What you should wind up with is that side B is 21.8 units long. So 21.8. And again, let's check and make sure it's reasonable. Is the biggest angle opposite the longest side? Yep, it certainly is. Is the smallest angle opposite the shortest side? Absolutely. It's not a guarantee that you got it right, but at least to make sure you're making sure your answers are reasonable. Okay? Have a wonderful day, everybody.